STS-124, with its international crew of 7 astronauts, will bring hope to the International Space Station. The crew will deliver and install the centerpiece of the laboratory complex known as Kibo, the Japanese word for hope. The 35th flight of Discovery marks the 123rd Space Shuttle flight and the 26th shuttle mission to the space station. This will be the second of 3 missions that will complete the Japan Aerospace Exploration Agency's Kibo laboratory. Discovery's commander is Mark Kelly, a native of West Orange, New Jersey, who's making his 3rd flight aboard the shuttle. Kelly is one of only 2 members of the crew that have previously flown in space. He flew as the pilot of STS-108 in 2001, and again as the pilot of STS-121 in 2006. This will be his first flight as commander. Navy Commander Ken Ham will make his first voyage into space as the pilot of Discovery. Ham is a highly experienced pilot with more than 3,700 hours in 40 different aircraft. He will assist with rendezvous and docking activities, and will also fly the shuttle after it undocks and flies a 360-degree loop around the station near the end of the mission. Mission Specialist Karen Nyberg will also be making her first flight into space. Nyberg will serve as Mission Specialist 1 and will operate 3 different robotic arms: the Remote Manipulator System, the Space Station Robotic Arm, and the new Japanese robotic arm located at the forward end cone of Kibo. Air Force Colonel Ron Guerin will make his first flight into space aboard Discovery as Mission Specialist 2 and will make 3 spacewalks during the mission. Guerin will also back up Ham during rendezvous and docking and will serve as Discovery's flight engineer, working with Kelly and Ham during launch and landing on the shuttle's flight deck. Discovery's Mission Specialist 3, Mike Fossum, is the 2nd veteran space flyer on the crew. He completed his first flight on STS-121 in 2006, logging over 300 hours on orbit, including 21 hours of spacewalks. Fossum will be the lead for all 3 of the mission's planned spacewalks. The crew of Discovery includes Japanese astronaut Akihiko Hoshide, one of the first Japanese astronauts selected to train for flight aboard the International Space Station. Hoshide will install the Japanese pressurized module using the Space Station robotic arm and will be the first to float inside the lab once it's opened. One of the major objectives of the mission will be the exchange of Expedition 17 crew members. Station Flight Engineer and Science Officer Greg Shamatoff will remain aboard the station when Discovery departs. Shamatoff will spend the next 6 months on orbit, returning to Earth aboard Endeavour during shuttle mission STS-126. Discovery will bring home Station Flight Engineer Garrett Reisman, who has lived on the station since STS-123 delivered the first component of Kibo in March. The STS-124 crew will see its timeline vary from that of recent shuttle flights. The use of a special sensor and laser system to conduct a detailed inspection of Discovery's heat shield will take place later than usual. Because the Kibo laboratory module is so large, there is not enough room in Discovery's payload bay to carry the 50-foot-long orbiter boom sensor system robotic arm extension that is used to perform the detailed inspection of the shuttle. The crew of STS-123 left the boom extension on board the station in March, so the crew of Discovery could use it during this mission. Once Kibo is installed on the station, the boom will be returned to Discovery and used to inspect the heat shield later in the flight. Just before the shuttle docks with the station, Kelly will fly the shuttle to within about 600 feet of the station and perform a slow backflip called a rendezvous pitch maneuver. This space ballet is performed during every mission to allow station crew members to take detailed digital photographs of the underside of the shuttle for analysis by engineers on Earth. The highlight of the mission will be the delivery of the 2nd piece of the Japan Aerospace Exploration Agency Laboratory, Kibo. Kibo, also known as the Japanese pressurized module, is nearly 14.5 feet in diameter and over 37 feet long. The bus-sized module is the largest station component ever launched aboard the shuttle and will be the station's largest laboratory once it's attached.
It's its own little spacecraft in the sense that it has an environmental system, electrical system, its own computer system, its own robotic arm. It's going to be used for fundamental chemistry, fluid physics, regular physics, biology experiments. Some of those will come up at a later time, but it's going to be a world-class laboratory.
The Kibo laboratory complex will include 2 television cameras and 2 6-jointed robotic arms, the first of which will be delivered on STS-124. Next year, another shuttle crew will deliver the third and final component of Kibo, an exterior front porch to allow experiments to be exposed to space. Back on Earth, the installation of the large Kibo lab will enable the Japanese flight control team to begin work in earnest from its mission control center in Tsukuba, Japan. There are 3 spacewalks scheduled for the flight of STS-124. Each will last about 6.5 hours. On Flight Day 4, Fossum and Guerin will transfer the orbiter boom sensor system back to the shuttle from its temporary location on the station's truss, where it was stored during the last shuttle mission. The 2 spacewalkers also will conduct further inspection of a damaged solar array joint that enables the starboard solar arrays to rotate and follow the sun. Fossum and Guerin will demonstrate techniques that may be used to help clean contamination from the joint's rotating ring. The crew will then prepare the Kibo module for its removal from the shuttle payload bay. Later that day, Hoshide will install the module on the port or left side of the Harmony connecting module. On Flight Day 6, Fossum and Guerin will install covers and external television equipment on Kibo and remove covers from the module's new robotic arm. The first section of Kibo, the Japanese logistics module, was carried to orbit during STS-123 in March and installed in a temporary parking place on top of Harmony in preparation for delivery of the main Kibo lab during STS-124. On Flight Day 7, Nyberg and Hoshide will relocate the Japanese logistics module to its permanent position on Kibo, using the space station robotic arm. On Flight Day 9, Fossum and Guerin will participate in what is expected to be a truly spectacular spacewalk as they work to replace a depleted nitrogen tank on the station's starboard truss used to pressurize station cooling systems. Guerin will grasp the 550-pound tank while attached to the end of the space station robotic arm. Then, Nyberg will maneuver the arm in a windshield wiper move, carrying Guerin and the tank on a panoramic trip as far as the station arm can reach to a stowage platform on the other end of the outpost, called ESP-3.
So this maneuver right here takes about 20 minutes. And on the top here, I'll be almost 100 feet above the station, looking straight down on the aft side of the station and the Earth 250 miles below. So it'll be a pretty spectacular view and a pretty spectacular ride.
Guerin will then take a new nitrogen tank and reverse course, moving from the storage platform back to the starboard truss for its installation and activation.
We tend to get a lot of the accolades, but there are a lot of people that are behind the scenes that are certainly as critical as we are to the success of this mission.
There are people who train us, people who actually manufacture the module, the orbiter, doing work down at the Cape, all the flight controllers here at Johnson Space Center, as well as in Scuba Space Center, who's working really hard, long hours.
Everywhere you go, every center you go, if you go to the subcontractors, everybody from the people that are turning the bolts and the nuts and to the people who are designing things, you could see it in their eyes. You could see how excited they are to be a part of it, because really it's an amazing accomplishment what is being achieved on the ISS through this construction.
This is Mission Control Houston. We're about 33 minutes away from the crew wake-up call. That will start the crew's day for both the crews of Discovery and the International Space Station. A very busy day ahead of them. Mike Fossum and Ron Guerin, the two astronauts who will conduct the first of their 3 spacewalks this morning, have been camped out inside the Quest airlock for the last 7 hours and 40 minutes. They've spent the night inside that airlock at a lower pressure, about 10.2 pounds per square inch. What that does is it helps purge the nitrogen out of their blood and allows their EVAs to start quite a bit earlier than would normally be possible. There's 3 different spacewalks planned for this mission that keep the astronauts very busy. We'll take a moment to show you more details about each one of those spacewalks and the tasks that are ahead for Mike Fossum and Ron Guerin.
We start out on EVA-1 with the JPM in the payload bay. EV-1, Mike Fossum, has moved down to the port side of Node 2, where he will be working with the shuttle robotic arm operator to coordinate a task to remove 2 launch restraint straps from the elbow camera of the arm. These straps were flown in place to keep the elbow camera from vibrating during launch and perhaps impacting the radiators on the payload bay doors or the GEM module itself. After the straps are removed, they'll move the arm away and perform a quick pan and tilt check to make sure that the camera is able to rotate. When Mike is done with this task, he'll move over on the port side of Node 2 to the Active Common Berthing Mechanism, or ACBM. This is the port where the JPM will be berthed later on this flight day. He'll inspect the surfaces and make sure everything looks like it's supposed to, and then he'll also open up a window cover that's in the center of this view. It's not shown here in the video, but the porthole that you see in the middle is what would be covered by that window cover. He'll open that up so the IV crew or the crew inside the vehicle can set up a camera that will aid in the berthing of the JPM to this port. He'll then move down to the Nader ACBM and repeat that same operation on this window cover. And this is the port where the MPLM logistics module will be mated during the ULF-2 flight. When he's completed that task, he will translate up to the front face of the truss, where he will go on to the mobile transporter to complete the ready-to-latch checkout that we talked about earlier. And from this location, he'll also, when he is completed and the boom has been released from ISS, which is what EV2 is working on currently, he will work from this position to help release the keep alive umbilical from the boom. So here's the ready-to-latch indicators. So while EV-1, Mike Fossum, is completing all of those tasks, Ron Guerin will be working on the starboard truss to prepare the boom to be handed off to the station arm, which will then take it and hand it off to the shuttle arm. His first task is this keep alive umbilical has several Velcro straps that he will release, and that will allow the cable to have some slack so that the station arm can move the boom around a little bit while we're releasing it from the station, and then we can keep it powered for as long as possible so that our power down time for the sensors is minimized. The second task that Ron Guerin will be performing is to translate to the midpoint of the boom, and he will be working on this first of 2 OSEs, or orbital support equipments. These are the stanchions that are mounting the boom to ISS. He releases the first one, and when he is complete with that, he will give the station arm operator a go to complete their rigidization of the SSRMS, or station arm, to the boom. When he is complete with that, he will translate down to the outboard side of the boom. And out here, he's got 2 tasks to complete. The first one is going to be to remove a bag, which we'll show shortly here, which was installed over the sensor package area by STS-123. This protective cover was put in place to help protect the sensor packages thermally and also from orbital debris during its stay on orbit. The next task that he'll be completing is to release the second of the 2 orbital support equipment structures here. And once he's released this, the boom will be completely under the control of the station arm and released from the truss. At that point, both crew members will meet back up at the inboard side of the boom. EV-1 will climb out onto the boom to release the keep alive umbilical. So there's some choreography here with the ground team to put the inhibits in place, and we'll start our thermal clock as soon as those inhibits are in place. And EV1 again will release what is called the CAD, or Keep Alive Umbilical Attach Device, which is the part that actually structurally attaches the umbilical to the boom. He will hand off that piece of equipment along with the cable to EV2. EV2 is going to finish cleaning up that work site and stowing the cable and the CAD, while EV1 at that time will move off to the payload bay to begin preparing the JPM for removal. The last part of the cleanup for EV2 is to go back and revisit both of these orbital support equipment structures. There are several rotational joints on each that he will lock out to their most rigid position in order for it to be in a good configuration for it to stay on orbit. When he's complete with that, Ron Guerin will move to the airlock and drop off a bag full of some tools that he was using for the OBSS release, and then he will translate down to the payload bay to meet up with EV1 Mike Fossum. Both crew members will translate down the port sill of the payload bay, and they have two main tasks to complete in the aft portion of the payload bay. The first one is completed by Mike Fossum, which is to remove some heater cables called LTA cables, and these power the shell heaters for the module while it's in the payload bay. He'll remove those cables and then stow them on a stanchion on the sill of the vehicle, and then both crew members will work on removing 8 contamination covers from the passive common berthing mechanism, or PCBM. This is the surface that will mate the JPM to node 2. Each of these covers will be removed by Mike Fossum and handed up to Ron Guerin, who will then stow them in a bag. Once he has received all of those covers and packaged the bag, he will translate back down the port sill with that bag to the airlock to stow it. EV1 will also translate back down the port sill, but on his way out of the payload bay, he will stop off on the forward side of the payload bay on the JPM, and he will be working on one of 2 window shutters. There are 3 bolts that lock the window shutter in place for launch for each of the window shutters. He will work on what will be the forward window shutter once this is installed on station. The aft one, which is just immediately to the right of that one, is partially obstructed by the GEM RMS end effector, so we will save that one for EVA3 when the GEM RMS has been partially deployed. The last task for EVA1 is the tasks out on the starboard Sarge. Both crew members will be out here. They will be working in parallel on different tasks. EV2 will be working on the trundle bearing assembly, while EV1 Mike Fossum works on an inspection of the data may surface and some cleaning DTO activities. So here is the trundle bearing assembly that Ron Guerin is installing. It has 2 parts. There's a mount assembly that attaches to the inboard ring, and then there's a bearing assembly that attaches to the mount and then clamps 3 roller bearings around the outboard ring. And this basically allows the outboard ring to rotate relative to the inboard ring. There are 12 of these total installed on the Sarge. This flashing point is actually the place where the trundle bearing is being installed, and then they will reinstall the protective cover on the Sarge. So while Ron is completing that, Mike will be removing 2 protective covers from the Sarge to give himself enough race ring to work with for all of the DTO objectives, or the detailed test objective for the cleaning DTO. This is the data may surface, which is what he'll do first. This is the area of interest that was investigated on the last flight with a crew equipment hook, which is a fairly rounded piece of hardware. We will revisit this spot with a little sharper tools to be able to try to get a little bit better tactile feedback. So here we have a crew member using what is the feeler gauge. It's normally used for RCC repair techniques. We are flying one specifically for this task, and it has not been modified, but will be used for this particular function. He will drag the tip of this across the area of interest to determine whether it is a divot and therefore maybe the start of some damage to the ring, or whether it's a deposit. The next task is in relation to the damaged outer candid surface, and this is the detailed test objective to try out the cleaning techniques. So Mike Fossum will use a suite of tools, the scraper probably being the main one, which is pictured in hand here. And then he's also got what amounts to basically a large flathead screwdriver, which is on the left side of your screen. He'll have some brake coat and a grease gun that looks basically like your standard caulk gun that he can apply and spread on the ring to see if that helps remove debris. And here is a glove box test where we pressurize the gloves to make sure that they have good tactile feedback between the tools and the work site. When he's complete with all of these tasks, he'll reinstall the protective covers. The crew members will clean up the work site and head back to the airlock. And that will complete all of the tasks for the first EVA on the mission. For EVA2, we can see the configuration is updated and the JPM is now installed on the Node 2 port side. The crew will be working mostly on the end cone on the port side of the JPM for their preparation out here. The first task for EV1 Mike Fossum is to install one of two of the camera groups. This camera, again, is used to view the GEM RMS clearance views. This camera is called a JTVE, or a GEM television external camera. It's one of the two that will be installed. These cameras will also help with views of the exposed facility after it is installed on Flight 2JA. So while EV1 is installing the aft camera, EV2, Ron Guerin, will be installing the forward camera, which is a mirror image of the one that Mike just installed. Both of these cameras will have a launch lock that will need to be removed to allow the camera to function. And once the crew is complete with all their tasks on the end cone and moved clear, the ground will power these cameras up and verify their functionality. The next task for the crew members is to move to the robotic arm on the JPM. It's called the GEM RMS. There are 6 joints. Each of those joints has a thermal cover, and then the end effector also has a thermal cover, so 7 covers total to be removed here. Here they are labeled. Covers 1 and 2 cover up the shoulder joints, and then 4, 5, and 6 are known as the wrist cluster, and then there's the end effector. Cover 3 is out of view here, but we have another picture for that, and is on the nadir side of the module. I think we have a short video here showing the crew at the Kennedy Space Center removing cover 3 on the flight hardware. Each of these covers will have 2 quarter-turn fasteners that hold it in place. The crew will release each of those quarter-turn fasteners, which will allow the cover to come off. Once the cover is removed, you can see a shiny silver object on the lower part of the screen, and that is actually the joint electronics unit, the electronics for each joint, and that is what we're actually protecting with this cover. Each of the covers also has 2 grounding wires that the crew will disconnect. Those are just connected with the Velcro to the joint itself. After the covers have all been removed and packed in a bag, the crew will move to the zenith side of the JPM to begin preparing the zenith active common berthing mechanism for the JLP relocate, which again will occur on flight day 7. The first task is to remove a 2-part MLI cover that covers the entire surface of the ACBM. These are 2 fairly large covers that the crew will remove and then stow in a bag. Here's a picture of the flight hardware of those. And then with the covers removed, the berthing mechanism underneath. The crew will inspect all of the surfaces and make sure the ACBM looks as it should, and then we'll remove a pit pin from the hatch mechanism, which is actually a launch lock for the hatch mechanism. And then the last task on this is to release a couple of launch locks, a couple of bolts really, that are holding these deployable MMOD shields in place for launch. We'll see these a little bit more on EVA3, and it'll be a little more clear how they're used. But these basically deploy to protect the mating surface between the JLP and the JPM from orbital debris. The last task on the JPM is to install trunnion covers. The trunnions are these metal posts that help attach the module in the payload bay. On orbit, they form a heat sink, so we install these covers to help prevent any concerns of condensation inside the vehicle. After that task is complete, the crew will move off to work on the preparation of their nitrogen tank assemblies. EV2, Ron Guerin, will move off to the starboard nitrogen tank to prepare that, while EV1, Mike Fossum, will work his way out to ESP3 on the port side of the truss to prepare the spare nitrogen tank assembly. On his way, he'll pick up this APFR articulating portable foot restraint. This foot restraint will be the base that he'll work from on EVA3 to remove the spare NTA from ESP3 and temp stow it on the opposite side of the platform, which will be more clear again on the video for EVA3. So he'll translate that out here, and then he will install that foot restraint on the zenith side of the ESP3. After that's complete, he'll open up a little MLI cover here, which exposes the NTA, or nitrogen tank assembly. He will release the 4 bolts. They're set for launch loads, and he will release torque on those and then reset them within the pistol grip tool's range to speed up the operation on EVA3. He'll also, on the opposite side of that NTA, install a couple of thermal covers over the quick disconnects to keep them from overheating during the translation between ESP3 and S1. While he's doing that, EV2, Ron Guerin, is moved to the back side of the truss, and he is going to work on the back side of the NTA on this side. He will open up what we call a shower curtain MLI here. It slides down. The NTA has some nitrogen lines that are connected between it and the ATA, or the ammonia tank assembly, which is immediately to the left there, the large box. So he'll disconnect the nitrogen lines from the ammonia tank and stow them on some dummy ports on the nitrogen tank assembly, and then close up the shroud. He'll also install the same thermal covers over the quick disconnects that EV1 did out at ESP3. The ground will begin venting the lines of the NTA to keep them from overpressurizing during the transfer from S1 to ESP3. On the front side of the truss, EV2 will complete a couple of tasks on the NTA to get it in its final configuration for EVA3. The first of the tasks is the same as what EV1 performed out on ESP3, and that is to break torque on all 4 of the bolts holding this to the truss and then reset them within the limits of the pistol grip tool. And then there are 3 electrical connectors that he will demate and then pull the cables back out of the way and stow them inside of the truss. At the end of this, the NTA is only in place by those 4 bolts that will be removed on EVA3, and then the NTA can be removed from its rails. When he is complete with that, he will translate out to the port side of the truss to join up with EV1, where they will retrieve the final item on this EVA, which is the external television camera group. This is on the far outboard side of P1 on the nadir side. The first thing they'll do is release a bolt and then install a handling aid to give them something to hold onto this thing with. Swing it behind themselves on their body restraint tether, and then they will work their way back to the airlock after they've cleaned up the work site and get this thing in the airlock. And that will complete all of our tasks on EVA2. Well, this is going to be a very robotic-intensive EVA. Ron Guerin will be on the station arm for a good chunk of the EVA for the NTA R&R. Because of the distance between the S1 NTA and the spare on ESP3, the crew will have to install what is called a whiff extender along with their foot restraint, and that basically, in effect, is just increasing the reach of the arm so that we can span the gap between these 2 locations. So the crew will set up the arm with that whiff extender and foot restraint, and EV2 will then ingress the APFR and begin to prep the NTA for removal. So Ron will release the 4 bolts that we reset on EVA2 and then install a handling aid to help him during the translation. And then he will, along with the help of the robotic arm operator, pull the NTA out of S1. While he has been completing all that, Mike Fossum has been working his way down to ESP3 on the port side of the vehicle, where he has gotten into the APFR, pulled back the MLI tent, and then he has released the bolts that are holding the NTA in place. He will then pull the NTA out, flip it over, and temp stow it on the opposite side of the ESP3 to get it out of the way so that when Ron gets here with the empty tank, he can install it directly into the housing on ESP3. So we'll see all that here in animation. EV1, Mike Fossum has now moved to the front side or forward face of the ESP3 in order to help guide the NTA into its position. You can see now as we move around that temp stow location for the spare NTA. Now the coordination between Mike Fossum, Ron Guerin, and our station arm operator will continue as they install this empty NTA now into the MLI tent. Ron Guerin will drive 1 bolt to make sure that the NTA is secured, and then he will remove his handling aid, move it over to the spare NTA. Then he will retrieve that spare NTA and begin moving that back to S1. Mike Fossum will stay behind and clean up the work site, making sure the bolts get all torqued down on the empty NTA. And Ron will get a nice ride on the station arm back to S1. He'll remove his handling aid and secure all of the 4 bolts. And then he's got 3 electrical connectors to go remate to power the nitrogen tank assembly. And then he'll remove all the hardware from the station arm so that it is unencumbered to go about the rest of its tasks. Mike Fossum is going to take the foot restraint that he installed on EVA2 back from ESP3 and translate it back down to the lab. We need to remove this APFR so that the ESP3 can be relocated during the stage. After he's complete with that, he will move his way out to the JPM, where he will begin the task that we outlined earlier. His first task is in reference to the two cameras on the robotic arm on the GEM. First one is the WVE, or wrist vision equipment. He'll remove the launch lock and MLI cover, or thermal cover, and stow that in a bag. Then he'll move to the EVE, or elbow vision equipment. It has a similar launch lock and thermal cover that he will remove. The last item here on the end cone is to remove the 3 launch lock bolts from the aft window shutter. And now both of these window shutters can be opened and closed by the crew inside the vehicle as they desire. Mike will then work his way to both sides of the JLP, actually, to deploy these deployable MMOD shields shown here. There's actually a separate handle to deploy each. This is the handle that Mike will access in order to deploy the shield. He'll rotate this handle out, and then it slides along a track down in this picture. And as he slides that down, this MMOD shield actually deploys. And again, that is protecting the mating surface between the JLP and the JPM from any orbital debris. Last thing to do is to close or stow the handle in its locked position, and then close up the door. So while Mike is working on all of that, Ron will be translating back up to the backside of the starboard truss here to connect the nitrogen tank to the ammonia tank. Once again, he's going to open the shower curtain, and then he will disconnect the nitrogen lines from their temp stow location on the NTA, or the nitrogen tank, and then route them over to the ammonia tank. After he's complete with that, he'll close up the shower curtain. He's then going to work his way down to the station airlock, where he will pick up the external television camera group, which was left in the airlock for thermal reasons. He'll pick that up and translate it out to the port side of the truss, again to the far outboard side of P1 on the nadir side, and meet up with Mike Fossum to install this camera. That will complete the end of EVA 3 and the end of all of our spacewalks for this mission.